Hello everyone, in this video we are going to discuss about 0 or 1 knapsack problem, and we are going to solve that using backtracking approach. We know that knapsack problem has two variations. One is fractional knapsack, the other one is 0 bar 1 knapsack. Fractional knapsack will allow us to take a portion of the item as well, where in 0 or 1 knapsack we are having a restriction that either we can take the complete item or we should not take that item at all into our sack. And the 0 or the knapsack problem is going to have four values as input. One is the number of items, the other two are weights and profits of each and every item, and the important input is the capacity of the sack. And in this video we are going to discuss a variety of 0 bar 1 knapsack. A variety means we are given with n number of each and every items, which means we have 3 items, and one variation is that we can take each and every item any number of times. Means we can take item 1, say for example 5 or 6 number of times. That is possible, that is allowed in this variation. So far we haven't seen this kind of problem. This is one of the variations of 0 or 1 knapsack problem. Alright, and now we can solve this using backtracking approach. This is the problem instance. We are given with 3 items, I1, I2 and I3, and weight of I1 is 4, I2 is 3, I3 is 5, and the associated profits are I1 has profit 10, I2 has 12 as the profit, I3 is having 15 as the profit, and the capacity of the knapsack is 8, which means we cannot exceed the capacity 8, and our objective is to maximize the profit. So it's not necessary that we need to completely fill the sack. That is not our objective, but our objective is to achieve maximum profit without exceeding the capacity. We can exceed the exact 8 or less than that also, but the profit should be maximized. Alright, and as usual we are going to construct state space tree. We are going to follow backtracking approach, and we are going to define the structure of each and every node as well. Each and every node in this state space tree is going to have two data elements. What are they? So they are going to have the weight in one of the elements, and the other element is going to be the profit. And how the weight and profits are going to be calculated, we'll see it in the example. And the root is going to be the initial condition of the problem, initial state of the problem, where we haven't taken any of the items into our sack. So the total weight taken into the sack is 0, total profit achieved at this point is 0. So that is going to be our root node. We are starting from this state. Alright, now since backtracking approach is using DFS, a depth first search, or in some other cases we can say it as inner traversal, it will go and construct the left child first. Alright, so what is going to be the left child of this root node? Now we are going to try and take the first item into the sack, and now the weight is 0, the weight taken into the sack is 0, profit achieved is 0. Now if we take item 1 into the sack, so we will be taking weight 4 into the sack, and we will be able to achieve 10 as the profit. That is going to be the value in this node. So we are going to have two elements. So weight is going to be 4, profit attained is going to be 10. Now since we are discussing about a variation of 0 bar 1 knapsack, we will be able to take one more item, one more instance of item 1 as well. Now we will be constructing the left child of this node. Means we will be checking whether we can take item 1 again without exceeding the capacity. So that is a variety, that is a property of this problem. We can take item 1 n number of times. So now we are checking whether we are able to take item 1 again. Yes, we can, because the capacity will become, the total weight become only 8. That is the capacity, it's not exceeding the capacity. So weight is 8. The profit attained, already we have 10. Now if we take 1 again, we will be having 10 more as the profit. The total profit will become 20. Now we'll try and check whether we'll be able to include any other item also in the same path. Since we are following DFS, it will keep on constructing its children. Alright, so 8 and 20 is the weight and profit of the current node. Now the capacity is already 8. Capacity is only 8. Weight achieved, weight taken into sack is already 8. So there is no way we can take any more items. So 1, 2, 3 will not have any other option. We cannot take 1 or 2 or 3 into our sack. So we'll backtrack to this previous node, the parent node. So the blue lines are indicating the backtracking steps. So now we are in this state. in this node 4 and 10. Now we are checking whether we can take item 2 into the stack. So what is it weight of item 2? Item 2 has 3s weight. So if we take item 2, 4 plus 3 will become 7. So we have taken weight of 7 into the stack. What will happen to the profit? Already we have 10 as the profit. Now we have profit of item 2 was 12. So the total profit will become 22. Now we will still go and check whether we will be able to include any other item also. So we will be checking whether we can include 1, 2, 3 or again. So 7 is the weight. So 1 has weight as 4. It will exceed the capacity 8. So item 2 is having weight 3. Item 3 is having weight 5. So we cannot take any of the items after this step. So there is no, we will not be able to construct this tree, this path further. So we'll backtrack the previous step and we'll be checking whether we'll be able to take item 3 into this stack. What is the weight of item 3? 5. What is the current weight? 4. So total will become 9. So that will exceed the capacity. So item 3 cannot be taken into this stack. So we'll backtrack to the parent of this node. That's the root node. So means we have one more option whether we'll be able to take item 2 into the stack. So this path is for taking item 1 as the first item into the stack. Now we are exploring another child of root node by taking item 2 as the first item into the stack. So what will happen if we take item 2, the weight is 0. If we take item 2, the weight will become 3, profit will be 12. Now then again we will try and check all the possibilities whether we will be able to take item 1, item 2, item 3, like that. So if we take item 1, the weight will become 7, profit will become 22. So 12 plus 10 will become 22. So we will not be able to take any other items. So we will backtrack to this node and we will check whether we will be able to take one more instance of the same item. So we have taken item 2. Now we are trying and checking whether we will be take item 2 again into the stack. So item 2 has weight as 3. So it is possible to take item 2 again. Total weight will become 3. Total profit will become 24. And after that we will not be able to any more item because they will exceed the capacity of the stack, which is 8. I will backtrack to this parent node again. Now we will be checking whether we will be able to take item 3 into the stack. Item 3 has 5 as weight. Now the weight is 3 only. So if we take that item also, the total weight will become 8 without exceeding the capacity. The profit will become 12 plus 15, 27. So after that point we will not be able to include any more item. So we will backtrack to this node. We have explored all the possibilities. So we'll be coming back to the root node and go to the other option, taking item 3 as the first item into this stack. If we take item 3 as the first item, the weight will become 5, profit will become 15, and we will not be able to take item 1 because item 1 has 4 as the weight. That will exceed the capacity. So will we be able to take item 2? Yes, we can, because it has weight only 3. So if we take item 2 into the stack, the weight will become 8, profit will become 27. After that we will not be able to include anything because the stack is already completely filled. Now we will backtrack to this node 515 and check whether we will be able to include item 3 again. So item 3 has weight 5, so that will exceed the capacity, so we will not be able to include. So we will backtrack to the initial. So these are the different nodes that we will be able to construct in the state space tree for this problem instance using backtracking. Now if you look at all the leaf nodes, our objective is to maximize the profit, and we know that the second compartment in each and every node is having the profit value, and now we will be taking the maximum profit among the all possible leaf nodes. So we have 27 in 2 places. So 27 is the maximum among the all possible total profits. So 27 and 27. If you backtrack to this root node, so this 27 was achieved by taking item 3 and item 2, and this 27 was achieved by taking item 2 and item 3. So in the end we have achieved the total profit of 27 by taking item 2 and item 3 into our stack without exceeding the capacity 8, and that is the solution for this 0 bar 1 knapsack problem instance. So as I said, we have discussed a variation of 0 bar 1 knapsack where we tried and checked if you are allowed to take more than one instance of the same item, what will happen. And this is the backtracking solution of 0 bar 1 knapsack. And thank you.